Hello, hello. Oh, lost my board again. Hello, Marina. Hello. Awesome. Who else?
Hello.
Hello, hello, Eugene. Hello. Well, hello, Ashton. Hello, Eugene. Hello, Marina. Oh, and there's hello. Hi. Oh, here we go. All right. Good afternoon, Sylvie. That's awesome. Hello, Marina. Oh, Sylvie was first. I'm sorry. I should have said good afternoon, Sylvie. Hello, Marina. Hello, Fatima. Hi, Devin. Hello, Abigail. Hello, Jonathan. Okay. Hello, Ashley. Hello. Hello. Okay. And hello, Kayla. That's awesome. Okay. Hello. Hello. Okay. Um, and good afternoon, Slady. Yes. Okay. Oh, there was my board again. Okay. Okay. Um, we actually have a lot. There's a lot of things I want to start getting to. We're not going to get to all of them today. I don't want to just lecture at you for 2.5 hours today. I keep saying that I'm not going to do that, and then it keeps happening, and I don't think it's good for anybody. Well, maybe me. But I know there's I there's stuff and stuff and stuff. Hopefully, still all of our concerns are hopefully intellectual, not academic. That is to say, I think we're all doing fine. I think we're going to keep doing this work and we're going to keep doing fine. We're going to keep learning and the grades will work out fine as long as we keep doing what we're doing. But I understand there's still homework questions we need to go over. You'll notice nothing new has been assigned for homework. This assignment this most recent assignment is giving some of you guys concerns or stress or whatever, which I totally understand. And I want you to take it seriously. I don't want you to just not care. I'm glad that people are caring, but I also want you to understand that I understand. So we're going to get through this assignment before anything new is assigned. Okay, so I'm glad we're concerned about the right answers in getting there. We will get there, but don't think that you're being punished for the fact that we don't know the answers yet or something like that. What I'm saying is nothing new is being assigned. We're going to work our way through these assignments as a group until they're worked out for everybody. There's also lab 3 or the most recent lab that I really also want to address. But in any case, we're not going to get to everything today, and we're not going to just sit here talking for 2.5 hours. But I am going to admit more people into the room. Okay. Our goal is to keep learning everything to get through this second assignment, and to understand what's going on in the labs. So I'm going to just begin. All right. I'm really going to try hard. I want to begin with explaining something that I think will help with where we are in the homework. So forgive me. I'm just going to go. Here's where I am. Okay. This is general lecture note taking right now for the moment. Oh, and there goes my board again. Oh wait, something in the chat. Hold on, I'm just looking in the chat. I see there's something in the chat. Oh, okay. Thank you very much, direct chat person. Got you. Thank you for looking out for one of your colleagues. I totally get it. Okay. So, all right, what's on the board here? This is ultimately what I'm about to explain is something that I think will help everybody with the end of homework 2. I want to explain it in its abstraction first, and then we'll apply it together but this is all about the barn door problem at the end of homework 2, if you're trying to track this. Okay. what I have on the board here is one of your first discoveries from one of the first labs, right? You discovered that period is directly proportional for an oscillator. Oh, here comes another one. You discovered that for an oscillator, the period of oscillation is directly proportional to the square root of mass, right? You discovered that there's that direct proportionality. What we tried to explain last time, I mean, or we sort of reviewed in practice last time, is that's not an equation, right? That's not an equation. It means that T equals, the period equals some constant times the square root of the mass. It means that what we know is we found out last time, for example, if you quadruple the mass, that would mean you necessarily double the period. Or if you multiply the mass by 9 times, then the period necessarily goes up by 3 times or something like that. So that's what direct proportionality means, that whatever you do to one side of the equation, you do to the other. It means we know that the rise per run of the function is a constant, right? But it doesn't give us an equality. We don't know what the constant of proportionality is. We know there is one, but we don't know what it is. So in other words, to all of us, right now, we're at a stage, we're still in a stage where we have experimentally figured out for ourselves that period relates to mass in this fashion, but we don't know what the exact relationship is. And it would be about time for us to know. Like, it would be helpful if we knew. So what we really need to know is, what is that constant, right? And that's what I want to sort of develop for you right now. So I want to finally, once and for all, get an equation for the relationship between period and mass. An equation that, of course, is flying around the internet. I mean, like, it exists already, but I want us to be able to feel like we have it. So, sorry, hold on. Wrong. No, what? No, not again. God, I don't know why I swallowed a fly. Perhaps I'll die. Okay. Okay. Let's, okay. So the goal here, so we know that T is equal to some constant times the square root of M. The question is, what's that constant? That's what we want to figure out. Okay. I think I did. Yes, I've mentioned this once before, right? Okay. I think I've mentioned this before, right? There's different types of variables, independent variables, dependent variables. There's different types of constants. One type of, like, there's universal constants, natural constants, like Planck's constant, or like capital G, the universal gravitational constant, or the charge of an electron is a universal constant. Like, there are constants that are just true throughout the world. Then there's constants that are constant in a given experiment. And one type of constant in a given, well, let me see. No, don't do it again. For a given experiment or a given system, in this case, the system of the mass going back and forth on the spring, there's different constants involved in our experiment. One type of constant is like X naught. X naught is a constant, right? The position that the mass was at t equals 0. That is a constant because once you set it up, that will always have been true. It will always be the case that the very first position the mass was ever at was 15 centimeters from equilibrium. And it will always be true. It will always be true that will be its maximum displacement from equilibrium. That type of constant is called a condition or configuration. That type of constant, X naught, A, that type of constant is a condition or a configuration it has to do with how we chose to set up the ingredients of our experiment. Everybody in the room could be given the same ingredients. All lab groups could be given the same mass and the same spring with the same stiffness, whatever. But if one group holds the mass back to initially at 15 centimeters, and another group holds it back initially to 12 centimeters, that's two different X naughts. That's two different conditions. Okay, that's one type of constant. But as I think I mentioned 2 weeks ago, mass is not a condition. It's a parameter. It's a constant material property of one of the ingredients in your system. If everybody in the room was given the same mass, then then that's the same for everybody, no matter what they do with it. That's called a parameter. So what we found out, like in the first week of lab, is that the period of oscillation depended or was determined by this parameter. We're trying to this parameter times some kind of constant. We're missing the other constant. Our search right now is to figure out the other constant in the equation, t equals blah times square root of m. So my question to the whole group, to all of you now, is it's not a trick question. I know I've just been babbling already for the last 10 minutes. My question to everybody is, can you think of any other parameters in the mass spring system? Like M is a parameter. X naught is a condition. Can you think of any other constants, any other values in our mass spring setup that you would consider a parameter, that you would consider, and hint, I already actually mentioned it like 5 minutes ago, sort of by accident. Can you think of any other, because what I'm arguing is our missing constant that we're trying to determine, like we're trying to figure out the constant of proportionality. We're trying to figure out what number or term or value goes right here so that we can finally once and for all have an equation for period. It's the period so far seems to depend on one of the parameters on our experiment. If we're trying to figure out the other constant, what I'm arguing or guessing or conjecturing is that maybe the other constant has to do with any other parameters that haven't been used yet in this equation. Are there any other So can you tell me in this diagram, in this system, a mass on a spring with a certain stiffness? Oh, and there goes my board again. It's about to. Oh, awesome. Awesome. Thank you. Even though I just lost my board, I think I do see in the chat that at least, but you know what? Okay, I shouldn't. One person in the chat is saying something. So first of all, that's awesome. Thank you. Second of all, that person may or may not be saying the correct thing. I would like to, but since that person is using the direct chat, which I really appreciate, I'm going to wait for a minute. First of all, I think I'm about to lose my board again, but I'm going to say, can I get a couple other answers in the direct chat, right or wrong? I'm going to repeat. So I'm going to wait till I say the answer. The question I'm asking again is, there's another thing in the direct chat. This is awesome. Okay, that's 2 in the direct chat. I'm going to go for a hat trick. I'm going to wait till there's a 3rd thing in the direct chat. I don't care if it's right or wrong. I'm just going to repeat the question one more time. And there goes the board. I knew it. I knew it. That's the board's way of saying you're being like a kindergarten teacher, dude. And then I'm saying yeah, but it's Zoom. Remember that show Zoom? Hold on. Let me just get this back in. Remember the show Electric Company? So loud. Okay. The lab was good. I know. I found Mr. Rogers creepy back then too, but he's such a good man. Was such a good man. Come on, don't make fun of him. It's so mean. Also, why are you talking to yourself? Okay, there's the board. All right, I'm waiting. So I'm going to repeat the question one more time. I'm going to wait. The question is there any other parameter in the mass spring system, in that diagram that was just on the board a second ago? Can you think of any other parameter at all that hasn't been mentioned yet? Any other parameter besides mass? And the 2 people in the chat, I'm totally going to say they are right, but I would like to hear from, so thank you, 2 people in chat. But I would like to hear from one more person. I would like to feel like I'm a worthy human being. There's a nice total hat trick. Okay, there are 3 people in the chat. They are all correct. Now, what does that tell us? I don't know what it tells us, but that's awesome. Yes, so that's good enough for me. We're going to call that a class. I'm going to say, thank you, person number 1. Thank you, person number 2. And thank you, person number 3, for all saying that the other parameter in what in the name of Nebuchadnezzar just happened? Hold on, excuse me. That was weird. I know what actually happened, but that's never happened before. Okay. The other parameter in mass spring system is K. Right, like mass was one and spring was the other. Right, these are the 2 oh, and that's someone else is in the chat. Wait, does that mean 4 people actually got this one? Oh, there's an emoji. I love the emoji. Oh, wait, and she went, she went public. Oh, that's awesome. Yes, and she's totally right. And she went public with a emoji. Wait, emoji. What doesn't matter? But with a what? Anyway, yes, thank you. Yes, she's right. I mean, Kayla is right. And the other 2 people who were in the direct chat said the same thing. Stiffness constant K. Yes. So what I'm conjecture. I'm conjecturing that our missing constant is somehow based on K. I'm trying to build up an equation for period here. Okay, and again, it might feel like a slow roll to all of you. Like, of course, many of you might be like, can you just give us the equation and can we please move on? Like, that wouldn't be, but you know what? No, because the truth is, one thing we're trying to emphasize and show you is that the actual practice of science, particularly physics is not actually about plugging into equations, even though it feels that way in 10th grade or physics 101 or something. Physics isn't about using equations to get answers. Physics is about developing equations, and it's particularly experiments are where we discover and develop or create these equations. That's the actual art of physics, is determining the relationships. Once we've got them, they're easy comparatively to use. So, I mean, that's what we're learning here. And what I'm trying to do right now is build up a T equation for oscillation. Now we know it's T equals, again, just to remind you, we're saying that T equals some constant times the square root of M. We don't know what the constant is, but now what we're conjecturing is that that constant is some kind of function of K. We're not done yet, we're getting there, but we're using logic to say, well, I mean, like the rate at which a mass on a spring goes back and forth, it seems to be based on like what the mass spring system is built from. Like M was a component in how fast it goes back and forth. That makes sense. Like if you if you change how heavy the thing is, you're going to change how fast it goes back and forth. And the only other thing you could change in the system is the stiffness of the spring. So it's reasonable to guess that, like, oh, okay, the spring stiffness must somehow be determining the rate at which this thing goes back and forth. But not directly. It can't be directly, because to put together this function, to figure out what we have to figure out what this function is, I think it's too easy. We cannot leap to the conclusion that the function is simply, oh, T equals K times the square root of M. For the simple fact that the units won't work out. So if that's the reason because T means period, which has to be measured in seconds. The square root of M means the square root of mass. Mass is measured in kilograms. So the square root of kilograms is just that, the square root of a kilogram. I don't think that the square root of a kilogram times K is going to give me seconds. But what I think I better do something to K in order to make this whole thing work out to seconds. Well, I better know what units K is in order to do this. I'm going to ask you this now. I'm going to pause. You guys in the direct chat, again, could be the same 3 people or not. In the direct chat, though, please, like not the public chat. Can you tell me, and I think this one's slightly harder, maybe. Can you tell me what are the units of K, of spring stiffness? What units is spring stiffness measured in? Oh, wow. Oh my God, that was fast. And by the way, well, you wouldn't know who, hold on. I'm very impressed. I'm getting some people in the chat that I don't always get to, which I'm really happy about. Okay, Gayla, if you could do the direct chat, well, I am impressed that you're going public. I think it might, if it's okay, I think it might be helpful for some people if we all just stay in the private chat but I know that's a weird habit, but hold on a second. Just responding. Oh, okay. Thank you. No problem. No problem. Cool. Cool. Wait. Wait, there's a lot of people in the chat now. Okay, this is good. This is good. All right. I am not going to respond to each person individually. Again, I hope you all remember, anytime you put anything in the chat, you could totally submit it for points. You should submit it for points. If you want more instruction on what I mean by that, I'll show you. There's different portals. Everybody that's putting it at all, there's, for example, the portal for right or for wrong. You could put all these things in there. You get points. If you're wrong, if I end up saying that something, even if I don't call you by name or whatever, but if it turns out you're wrong, there's a separate portal just for wrong answers where you get extra points for wrong answers. Don't forget that, please. So I'm not going to respond to every,
what should we do if it doesn't allow us to submit? Like, the only option for some of the portals for me, it says unsubmit. So I would have to unsubmit to submit like a new one, even though some of them weren't graded.
wait, that's interesting. Hold on a second. This is
Yeah, I can send
wait.
you like a screenshot of it too.
Wait, I totally believe you. But this keeps coming up every semester and confusing me. Hold on. And I don't want to, obviously, I don't want to spend the whole like class period on this, but just really quickly, because I think you just made me realize something. You're saying some portals do that and some portals don't do that.
Yeah.
Okay. And is it the portal where I haven't graded something yet where that happens? Is that what you're saying?
I think for one case it was, but then for the avatar ones, they're usually graded. But then this time, and usually I'm able to submit, but then this time it says unsubmit. Like, there's no option to submit something new.
Even in that avatar one? Even in that
Yeah.
one? Oh, okay. I'm glad you're bringing that to my attention. For a minute, I thought you just had a breakthrough for me. Like, for a minute, I was thinking, oh my God, maybe that's it. Is that if I have graded something, then you can submit more. But if I haven't, maybe you can't. But no, but it sounds like you're saying it's not that simple.
I think some are graded and some are not. So it's hard to determine like why some let me submit and some don't.
Right. Well, and you're right. You are absolutely right. And I know you in particular. I mean, I know you're taking advantage of these, and I have great. I've
definitely.
seen right. No, and that's great. You're doing what you're supposed to do. And I, for everybody, like, she is an example. Like, I do want it to be the case that you could submit multiple things to one portal without having to unsubmit. And apparently, occasionally, the system does tell you that you have to unsubmit. So I'll just say this. I feel like maybe a lot of the time that is just if I haven't graded it yet. Like, I feel like generally once I've graded something, it will let you do more, but there still might be something that I'm not understanding. But I'll tell you this, if ever that happens, like, just please, if there's something where you're trying to submit something new, but it won't let you, and it's like saying unsubmit, if at least right now, if it's in the case where that's still possibly because I haven't graded the other thing, then just send me a text and just say, could you please grade this so I can submit more? And I mean, I'll put my number in the chat again, or I mean, it could be an email, but I know text can be faster. Something. Hold on a second. Let me just put this for everybody. I mean, I know I'm talking. I know. Sorry, I know it's. Where did it just go? Wait, where did you just? Oh, I know it's Marina that's talking right now, but what she's talking about really applies to everybody. I really do want you all to know. Like, there's tons and tons of points that you can be getting. And I do mean it to be the case that, for example, like showing video or something that you could submit over and over and over again to the same portal and get lots of points. Like, it happens that, yes, Marina is a person who is taking advantage of that. So there, whatever, but it's meant for everybody. But what she's bringing to my attention, we'll move back to the material in a second, but just for everybody, like, if ever the thing tells you you must unsubmit before you submit, she is right that I do not prefer that. I prefer you to be able to show me as much work, any work that you've done, I want to be able to see, and I want you to get credit for. And I don't want you to remove things just because you've done an improved job. Like I love seeing that there's more than one draft or whatever. So for all of you, if ever you try to submit something extra, something new, and it's telling you to unsubmit, especially if it seems like it might be because I never graded the old thing, please send me a text and just explain, or an email, and just say this, and then I'll try to get to it and see what's going on. But okay, wait, if you
Great, thank you, Professor.
Oh, wait, no, thank you. Wait, what does it say in the chat? If you resubmit. No, I mean, it
I
shouldn't.
already answered it though.
Oh, I did. Oh, okay. Right. So we'll just try to work with this together. Okay. So moving on. Wait. There's also, I just resubmit everything. Yeah. Oh, and hold on. I'm just responding to some of the stuff in the chat here. We'll just catch up.
Because Remy said unsubmit, but then if something wasn't graded and then you unsubmit it, then it's gonna be like it was never there, and then you won't get the points.
I totally agree. No. I totally agree with you and Rem. I agree with what you're both saying. I would rather you never unsubmit things. It's true. And usually this works, but you're right. I know you're right. You're not making this up. Every semester this happens, that sometimes it seems like Google Classroom insists that you unsubmit in order to submit. And I don't want that. I'm trying to get to the bottom of what those conditions are. So when in doubt, just hold it. And you could also just text me to say, look, I've got something for you, but it's not letting me. Because in worst case scenario for all of you, I'll just open up a new portal if that's what I have to do. But I really want to encourage this idea. Again, I don't want to go off on a whole sidebar, but the reason I think this is an important issue for all of you, particularly at this stage of science, is I'm trying to break down the wall that we all have as science students and science teachers, whatever, science faculty. There's this wall where all of us are so afraid to make mistakes in public, or so afraid to put things on paper, that I'm not saying you guys, I'm just saying in the culture, there's so much of us hold our work back and work more slowly, or work more scared, or don't produce work because we're really afraid that we can't submit it or produce it or show it until it's perfect. And that's horrible. It's causing us all anxiety and causing us all to do less than we could do. So it is important to me to encourage all of you that whenever you have anything to show me, please show it. And I literally want to give you credit for wrong answers, as you see. And I literally want you to do tons and tons of revisions and get points every time you do them, because I want you all to understand that the idea in science, is to keep the beat going at all costs and not be fooled by the gatekeeping and the authorities and the stresses that say, we don't accept you until you're perfect. Everybody thinks that, and everybody passes that message on, and then everybody has a heart attack and nobody gets a job. And it's all not true anyway, because that's not what's actually, it's not what science actually is. But anyway, okay. You get my point. So I'll go back to, but that's why I'm taking seriously what Marina and Remy and everybody are talking about. Oh, no. Okay, I'm reading this. Hold on. I'm just. Yeah, usually Remy is right. Usually it lets you. Wait, you can unsubmit. Oh, unsubmit and resubmit. Oh, wait, is he saying? Okay, wait, I'm going to read. I know we should get back to the. Hold on, wait a minute. Oh. Oh, yeah, no, yeah, you can. He's right. I mean, sure. As long as you got points already, you can do that. Yeah. As long as you've gotten them, it won't remove the points. That is true. If you already got the points, you could do that. But I think we're also talking about a case of where, what if I haven't seen it yet and it's not letting you, but okay, I think but yes, everybody's right. Nobody's wrong. I mean, usually that's true, Remy, but sometimes it seems like sometimes it blocks you. I don't know, under weird conditions, sometimes I think but in general, as long as it doesn't, then good, then we're all good and I'm going to move on. But yes, when in doubt, the more points I can give you and the more points you can get is the better. I think we all agree with that. Okay. I'm going to do right. Okay, hold on. There's maybe an interruption in a second here. There might be an interruption in a second. They're here. Excuse me. Okay, no need to. Going back to K. So what I saw in the chat, I didn't respond to each one of you individually, but what I saw in the chat is that the units of K are indeed, as many of you put in the chat very correctly, they are newtons per meter. Because K is force per displacement. So yes, indeed, the units of K are newtons per meter. Now let's break this down even further. Can you tell me in the direct chat, please, can you break down a Newton for me? And the reason I want to do this, by the way, first of all, this is good practice that we always want to break down all units down to the fundamental pieces of MKS. But also in this case, particularly, I want to break it down to MKS because kilograms are the units of mass and seconds are the units of period. So I'm trying to manipulate these things so I can get them. I can change. Oh, very nice. Oh, I see. Oh, awesome. Oh, and I'm getting some new people. Not new, but I like the variety of people I'm getting in the direct chat here. Yes, so I totally agree with both people in the direct chat that a Newton is a mass times an acceleration, i.e. a kilogram times a meter per second squared. Awesome. So, all right, so K is a kilogram times a meter per second squared. Now, I'm going to ask you guys now. Here's the toughest one. Stop me if you're not with me so far, but we have that's the units of K. That's the units of K. We're conjecturing that somehow K or some version of K or some function of K is going to be put together with the square root of M in order to produce T, some version. I submit to you that you can play around with K and M right now to figure out a combination that cancels out the units properly. Like you want all those kilograms and all those meters to all go away and be left with just literally seconds, not seconds squared, but seconds in the numerator, right? So I'll remind you. So your goal is T equals So I'm going to ask you guys now. I'm going to pause. I'm going to ask you to, on paper, play around. Like, in other words, here's possibilities. Maybe it's K times the square root of M. Maybe it's square root of M divided by K. Maybe it's K squared times square root of M. Maybe I might even write out these choices if it helps more. I would recommend trying multiplying by K, trying dividing by K, trying multiplying by K squared, dividing by K squared, or maybe even multiplying by square root of K or dividing by square root of K. It sounds like a lot of choices, but if you just try one of them and you start seeing what goes right or wrong with the units, I think you'll get the idea fast what you have to do. But we want the simplest possible arrangement of K and M. We want the simplest possible arrangement of K and M that will produce seconds, right? And I'm going to pause and ask you guys, and I think this will take a little more time than before. In fact, I'm going to put you in breakout rooms for this. It'll be quick, but I think this is just hard enough. But wait, well, let me ask you, do you whether or not you think you could do the answer, raise your hand electronically if you understand the question. Okay, cool. Or physically, Ashton, cool. Thank you. Okay, Eugene, thank you. And thank you, Sylvie. Awesome. Thank you, Devin. And thank you, Kayla. Thank you very much. All right. So I'm going to put you in breakout rooms because I don't think it's crazy, but it requires a little bit of thought. So here we go. If I, okay. All right, so go to the breakout rooms. It'll just be for like 5-10 minutes, or or come back when you're done if you. But and so please join. Yeah, okay. Please go to breakout room. Thank you.
Oh, please, let's not get Luke involved. Patty was here to defend himself.
So please, Marina and Isabella, go to breakout rooms. Thank you. And Isabella, you're. Isabella, are you good? Are you there? Isabella.
No.
Isabella, are you there?
You know what's listening, thank you. Felix, all right. So, I'm hoping that will yeah. Have you been inside? I like it. It's it's like really open and it just has. Okay. And that's a lot of family. Or making a decision. No, I couldn't. Well. Because the thing that's like. It's so like. Hey, Felix, you're getting a little rough over there, my friend. I hear you're all having a good time, but sometimes things go just one step too far. Cause you're heavier. I think it's actually winter now. Unfortunately, like I thought I was just saying that. Yeah. So they were at the open hospital and I with us. Right. But and she was like, and yeah, like this way. Yep, yep. Say goodbye. I'll see you tomorrow.
I know. Let's see.
That was perfect. Okay. See you now. See you now.
Yeah, yeah, I'm still, and yeah, I'm.
Can I have that
Wait.
prize now?
Wait, no, I'm in the middle of class. I really look. Okay, wait,
Up, Felix.
I'm in the middle of.
Why can't I?
Wait, I'm in the middle of class right now. Please, wait, Felix. We're not having this discussion in the
You're
middle.
not doing anything.
I'm waiting for you. to-
Well, I'm waiting for you.
Wait, no, we're not doing this. Felix, do not do this when I'm in the middle of class.
Well, you know what happens on Wednesdays. I get it, and I want it soon.
No, Felix,
When are you going to be done?
don't talk to me that way when I'm in the middle of class.
When are you done?
7 o'clock.
When's 7?
Wait, Felix, stop.
When is 7?
In an hour and a half, but you gotta stop. I'm really excited to see you, but I can't talk to you right now. They're in.
As soon as you had this one, bring the pot.
Don't talk to me like that.
Use.
So my group couldn't come up with anything.
Okay. Wait, well, first of all, thank you for coming back. I was actually about to say, thank you for coming back. Thank you for reporting. Thank you for trying. Let's see, wait, other people are coming back now too. That's interesting. Okay. Well, let's talk about I'll wait till everybody, but thank you for telling me. And I don't even know who was in your, well, we'll see what the reports are from the other groups. Hold on a second. Who else? I think we lost some people in the translation here. But did you get any? Well, all right. All right. Hello. Welcome back, everybody. All right. Let me get some reports here. I'm glad people came back. At least one person has reported that their group hit a wall. What about other groups? Did anything happen? Oh, that's an actual video. That's awesome. Catherine totally is showing video. Okay. Sorry, Eugene, what were you about to say? Were you about to say something?
No, we were just discussing like why were we put in the group? I was thinking maybe it's like similar to what we did in the board meeting. So we can discuss which group, what we came up in each group.
Yeah. Oh, wait. Yes. Wait, but was it not clear what, was it clear what the question was, or was the question not clear?
Are you asking what the K is used for, or were you asking to find the C?
Right. I'm asking to find the C.
Okay, got it. I got it. Okay.
Oh, okay. So, and specifically so maybe this was, okay. Right. Our goal is to find the C. That's right. And specifically to use units to find it. Like what specifically I'm saying, maybe this wasn't clear to people. I'm sorry. What I'm specifically saying is I think C is some function of K. I mean, I'll walk you through, I'll do it now because I'm asking how can K be arranged to make the units work out? I can see why the question is not clear because every time I say it differently. Yes, our goal is to find the C, but the thing is, I feel like what we've come to figure out already is that C is based on K. It's not that C is K, but maybe C is K squared, or maybe C is square root of K, or maybe C is 1 over K or something. And I think the way we can figure it out is by looking at units. But apparently that was not clear. I will show everybody, right? I'm just going to verify. It sounds like at least Eugen and at least one other person from a different group is telling me like that they didn't. Oh, wait, hold on.
So that makes sense. I mean, I think it makes sense because the time is shown in K as seconds.
Right.
And then another formula is newtons over meter, which both goes into C. So I guess it's the problem of like how to convert them from two equations that we can use.
Right. It's yeah. That's right. So okay, so you do get the question. Good. Okay, I will show you. Unless there's anybody in the room, I'm just going to kind of infer from what Eugen and what Ashton are telling me. Am I right to think that everybody needs to see me do it? Like no group has an actual answer that they want to show. Is that correct? Or wait, no. Wait, there is something in the chat. Oh, there is something in the chat. There's one thing in the chat. I'm going to just, okay, wait, hold on one second. Oh, wait, I didn't even see. Oh, wait. Okay, okay. Okay. I'm just gonna say, all right, so my understanding is that most of the groups hit some kind of wall. I think evidently also maybe the question was not 100% clear to all the groups or whatever. I will say for the record that there's at least one thing going on in the chat where at least someone somewhere seems to kind of know what I'm saying here, but that's cool. That here's what I'm saying. Well, yeah, here's what I'm saying. Well, okay. Wait, I'll start first. Here's what I'm saying. Okay. I'm going to try something to show you what it is that I'm trying to do. Again, I'm not just giving answers here. I'm trying to show you the method of scientific thought here. That's what we're trying to learn. So bear with me. But what we're trying to do, we've got a bunch of data from the lab. We're trying to build up a relation. Like this is where equations come from in the first place. So this is the process. We already know that T is directly proportional to the square root of M. We therefore know that T is equal to some constant times the square root of M. We're now going to, we've also realized that that constant must have something to do with the spring stiffness, because that's the only other constant in the experiment that we haven't taken into account yet. So I'm going to try on the board. Oh, you don't see my board, of course. I'm sorry, you don't see the board. Hold on, here comes the board. I'm going to try. The first thing that comes to my mind I'm going to try to see what happens if I assume that the constant is K itself. Like I'm going to try the simplest possible thing first, which is what we always actually do in science, or we should do, or particularly in physics. Despite what it looks like, we're always hoping for the simplest possible solution. So I try, let's say that period equals spring stiffness times square root of mass, right? Well, I'm going to try that. Well, you know, period must be measured in seconds. So the left side has to work out to be seconds. Now the right side, according to you guys, K is newtons per meters. So the left side is kilograms meters per second squared per meters, right? That's the K. Excuse me. And then kilograms, mass square rooted means kilograms to the 1/2 power, right? So I'm trying this. I'm first trying that. Well, so when I look, what kind of simplifications can I make on the right and left-hand side? Well, on the right side, these meters cancel with these meters. That's nice. But seconds are in the denominator and they're squared. And the kilograms aren't canceling out with kilograms. They're being multiplied by kilograms square rooted. Like what I'm saying, and I'm not saying I just made a mistake. I'm showing you like the thought process. Like if I always try the simplest thing first. We're looking for the simplest possible explanation, but we try the simplest thing first and we find in many cases, oh, the simplest conceivable thing is too simple even to be possible. If I just multiplied square root of mass times K itself, the problem is I don't cancel out the kilograms. I need to cancel out those kilograms and just end up with seconds, right? The way the meters canceled out, that was good. But the kilograms didn't cancel out. Instead of canceling out kilograms, I multiplied them by square root of kilograms. That's a bummer. And then I have, instead of seconds in the numerator, I have seconds squared in the denominator, right? That's bad. Now, that's bad. It's not what I want. But what I'm also trying to show you as part of a larger science lesson is the reason we do trial and error, and the reason we write down everything that we think of, the reason we experiment even on paper, not just in the lab, is because the minute we see our first wrong answer, usually by looking at the wrong answer, we get major insight into what we need to do in order to get the right answer. Like if I look at this, I see a big problem with this is that we ended up on the right-hand side, we ended up with seconds squared instead of seconds, and we ended up with seconds squared being in the denominator instead of the numerator, right? That is a problem. If I were in the middle of an exam and I just did this, I might panic like, oh my God, I'm such an idiot. That's so wrong. Oh my God, I'm like an idiot. I hate everybody and everybody sucks. Right? But what I'm here to say is, but actually, wait a second. The fact that I can even describe what the problem is that gets me so close to the solution. If I notice, wait a second, by multiplying by K, I ended up with, first of all, okay, I'm going to ask you guys now. If the problem is I multiplied by K and I ended up with seconds squared instead of seconds, what's your first guess as to what we should do to K? Like what would be a better thing to do to K? If we don't want seconds squared, we want seconds. What should we do to K so that we get seconds instead? So I am actually asking you to put in the direct chat or whatever. If by, oh, awesome. That was really fast. You're totally with me. Yes, direct chat person. What the direct chat person said, oops, sorry, is they said, oh, you should do the square root of K. I totally agree, right? Like that seems out of nowhere. And again, 10 minutes ago, I mean, and that's what I'm looking for. And that's what, oh, and sorry. Oh, and someone else just said in the chat too. Yes, take the root. I'm with you. I'm good. This also, this makes me feel like we're making progress here. Like, oh, and that's another person. Oh, cool. Oh, awesome. That's a third person in the chat. Rock and roll, hoochie coo, Lordy mama, light my fuse. Yes, I did not just say that. Yes, I did. So first, what you guys are telling me is, okay, don't multiply by K then. Multiply by the root of K, which 5 minutes ago when I was using as an example, I think just went over everybody's head because it was like, it was just out of nowhere. Like, what's he talking about? Take the square root of K, blah, blah. But now that we try something and it doesn't work and we see how it doesn't work, we see, oh, maybe I should take the square root of K. Okay, good. And I'm going to go a step further. I'm going to go a step further and say, okay, also notice now that the second, oh, maybe someone else is in the chat, I think, but also notice yeah. Exactly, direct chat person who just went to, yes, exactly. So now let's take that logic and also go one step further. We also notice that the seconds squared are in the denominator, but we don't want them in the denominator. We want them in the numerator. So what should we do to not only, we should square root K, yes, and also where should we put square root of K? Should we put it in the new, should we multiply by it or should we divide by it according to what's happening here? Like, so Mike, yes, that was fast also. Yes, should I wait for one over? No, I'll keep going. Yes, we should divide. In other words, this indicates we should consider. What this indicates, I'm going to test it in a second. This starts to indicate, oh, wait, sorry. Oh, yeah. This is starting to indicate that this C number that we're looking for is either equal to, or it's close to, or it's directly proportional to. It looks like unit wise, this number that we're looking for quite plausibly should be some version of like 1 over the square root of K. Again, that sounds very obscure. Like, how can I expect us to just have come up with that? But actually, it's not that obscure at all. If we're walking through units, we see that. And I'm just going to test to show you what I mean. In other words, if we try the square root of M over the square root of K, or in other words, the square root of M over K, right? We would get kilograms square rooted, right? All over kilograms. Wait, here, let me put it this way. Yeah, all over kilograms square rooted times meters square rooted per seconds per meters square rooted, right? What did I just do? Right? I just did kilograms on the top, square rooted, and I did kilograms times meters per second squared on the bottom, square rooted. Like I just square rooted every single thing in kilograms meter per second squared, right? And if I do that, the meters cancel out, the kilograms cancel out, and we're left with seconds, which is what we want. So we're just about there. All right, should I leave that? I don't know if you do need. So I'm saying this is good. And there was one person in the chat that did put this, just for the record, like, and I'm impressed with that. Maybe I should say, okay. But so we're just about done. Now, remember, we're trying to build up, all of this is to build up an equation for period. Remember from last week, oh my God. There's something in the chat that is exactly what I was just about, or I think, wait, let me just. Right. Okay. Direct chat person. That's just what I was just getting at. That's really good. Remember from last week, I mean, in short, yes, with modification. But remember from last week, we have these 3 different ways of describing the same ultimate concept of the rate at which oscillation occurs, right? So yeah, remember. Remember, there's three different ways of describing the same thing. One way is the most intuitive, the most physically measurable and mentally visualizable. That's period. Seconds per cycle. The thing we measure in the lab, the thing we can most easily picture in our mind. Then on the other end of the spectrum, there's omega, angular frequency, the number of radians per second. That's the least easy to picture, the least easy to measure in the lab, but the most mathematically useful and powerful. They're all related to each other. They're all related ultimately. They all describe the same thing, but we need angular frequency because it's the most mathematically useful. But we get it from converting. Angular frequency is the most mathematically useful. Period is the most physically intuitive. Standard frequency is the bridge between the two, right? The thing that hooks together, the thing that connects what we can physically measure and mentally visualize easily, the thing that connects that to all the cosines and all the powerful mathematics that we extract from circles, the thing that links it all together is that one cycle equals 2 pi radians, right? So that's like the conversion factor between and among these three interchangeable measurements. I think we reviewed this last week. If I say that something is cycling at a rate of 3, if I say that something has an angular frequency of 6 pi radians per second, then how many cycles per second is it undergoing? I'll say it again. If something has a standard frequency, if something has an angular frequency of 6 pi radians per second, then what is its standard frequency? How many cycles per second is it undergoing? Oh, someone's here. I'll say it again. If an oscillator has an angular frequency of 6 pi radians per second, how many cycles is it completing every second? Right, let's do. I'm going to ask you, could you guys answer this example on the board, please, in the direct chat? Let's just make sure we're together here before I go any further. Phew. Awesome. And by the way, I'm going to stop right now. The person that went in the direct chat, you definitely want to submit for points. There's one person in the direct chat. I'm very proud and happy for that person. Oh, wait. It's even simpler than that. Wait. Okay. So the first. Hold on one second. Hold on a second. I'm glad people are participating. Thank you. Oh, that's good. Thank you. Third person. Okay. Hold on a second. Um, Wait, you know what I'm going to do right now? Hold on a second. I don't mean this in a weird way. I think I am talking too much. I'm doing it again. I'm talking way too much for anybody. I could tell because I'm actually asking a question right now that I know a lot of you actually know the answer to. And so I don't mean this in a weird way, but I think I'm talking way too much. What I'm going to ask, I'm going to shift gears here. I'm going to shift gears. One second. Hold on. I want I'm going to ask everybody right now. This is not, I'm just going to shift gears because I am talking too much and I totally did. I meant to not do that. And there were other things I want to do this period anyway. So let's pause for a second. We're almost there. Look, yeah, I want everybody to turn. I'm going to screen share this. We're going to turn our attention here. We're going to go back into breakout rooms in a second. By the way, also, we don't necessarily have to go, even though we have a lot to do. I don't need to go the full period just for the sake of it, even though I'm always saying that, because I don't want to pull teeth from anybody. So bear with me. We're going to shift gears here because I can see what's happening. I want us to go to this. I think I just lost my board. I'm not sure. Oh, no, I didn't. This is part of that homework too, right? This is Roman numeral 3. The question I just put on the board that sort of like a lot of people got quiet about. I think you really do know how to do it. I want you guys to do this right now. And I'm going to let me be as clear as I can. Everything I'm trying to build up right now about period being related to the square root of mass and K and all that, you don't need the result of it to do this. This you need to understand in order to get the result of it, but not the other way around. So I'm shifting gears right now just because I don't want to fight. I mean, we're not fighting. You understand what I'm saying, right? So I'm going to put you in breakout rooms. Some of you have already done this. Like technically it was due, right? But like many of us have not. Remember 1 hertz 1 hertz is a cycle per second. Okay, so I'm going to put everybody in a breakout room right now to do this thing that's on the board. Just raise your hand, electronic hand, if you understand what we're about to do. Like, thank you, thank you, thank you. All right, that's good. Thank you, thank you. All right. Oh, wait, let me look at what's happening in the chat. Let me just see. Oh, yeah, oh, cool. Cool, cool. All right. So we're going to do this and we'll see what happens when we, so let me do, breakout. I'm going to do, is this the same? Sorry. Is that the same? Okay, here we go. Okay. Oh, so lady, is your hand up? Do you have a question or are you just raising it from before? Okay. Okay.
Oh no, it was for some reason it didn't turn back off.
Oh, okay. Okay. So,
Before, yeah.
okay. Thank you. Hi, Giselle. I got your message. Thank you. I totally okay.
I have a question about the what we were just doing before. I just wanted to like ask you what you meant by me overthinking. I just wanted to ask. That's all.
Oh, yeah, no, that's good. And also, no, I'm glad you're, and actually, because I feel bad, because I really was gonna try to like, I really did want to give you some like office hour time during this class anyway. I was actually gonna change the whole class and make it all a bunch of office hour points, and somehow that got too hard to.
No,
But anyway,
it's okay that like it's no big deal. Don't worry about it. I can always meet with you next week. It's no big deal.
well, right, that is definitely, okay, I appreciate that. But okay, in terms of the overthinking, and I did mean it as, I'm glad you're asking, and I did mean it as a compliment.
Yeah,
It's-
no, I didn't take any offense to it. Don't worry.
Okay. So I'll work backwards. Like the answer that I was looking for, actually, like the answer was just the number 3. So it was
Oh,
like,
really?
yeah. So I think it was simpler than what you were thinking. So here's the deal. Like I'm saying the angular frequency is 6 pi radians per second. I'm asking how many cycles per second is that? Or like how many cycles is it completing per second? Well, what you're correct about, like the thinking that you're doing that's correct is you're thinking about 2 pi, and you're thinking that something about how there's 2 pi radians in every cycle. Totally all true. But then therefore, the whole deal is in a way simpler than you're thinking. It's just, well, if there's 2 pi radians in every cycle, and this thing is doing 6 pi radians per second, well, that means like it's doing 3 cycles. Like there's 2 pi. I'm just divide by 2 pi. In other words, if
That's it.
That's it. Right.
Because
That's
what
it.
I did is that I went through like I did the omega equals 2 pi over t, and then I did that, and then I put it into frequency 1 over t. I was like going crazy about it.
But here, right? But now, just for the record, and I know that came up in the office last. Like,
Yeah.
don't get me wrong. Like, this is a good example. Everything you're doing is still right. Like, you're not wrong. All of that should still work. That's all the correct stuff. And if we walk through it in a moment, like depending if it doesn't bother Sylvia, or if Sylvia has a question or whatever, like you're not wrong. That should all work. But it's enough steps that you're sort of doing. It's so many steps that it's easy to lose sight of what the basic logic is. So then you don't even know if you're making a mistake or not when you do the steps. If we do them carefully, those steps should still land on the same correct, answer. But right, so for example, you're saying omega equals 2 pi over t. I agree with that. So I gave the omega is 6 pi radians per second. So you're saying that should equal 2 pi over t. That means, in other words, the t should equal 2 pi over that, right?
Yeah.
Right, which is correct. Now it's hard to pick. In other words, you would take 2 pi and divide 2 pi by the thing I gave, by 6 pi, right? So you have 2 pi over 6 pi. It's correct. It's just like clunky and like, confusing, but it's correct.
I'm like doing it because I've been in chemistry brain for like all week. So it's like formulas. I'm going to use this formula to find this and that. That's kind of where I've been going.
No, I understand. And to every, and so let's just finish it though, just so that you can see, like if you do 2 pi, if you're thinking like chemistry, you have 2 pi over 6 pi, the pi's will cancel. So then you have 2 over 6, which is 1/3, right? It's still looking clunky, but it's 2. So what do you have now? You have that the period is 1/3 seconds per cycle, 1/3. But now what I was asking for is the frequency. I was asking how many cycles per second. You're saying that the period is 1/3 seconds per cycle. So if you're using your formula, if you're plugging into the formulas, the next step you would do is say, oh, I have T, capital T. He wants F, lowercase f. So F is 1 over T. Like you have, so I would flip your answer. You have 1/3 written there. So we would flip that and get 3. And that's actually the answer, 3. Does that make sense?
Okay. Yeah, I just forgot to cancel out the pies, I guess.
Oh, okay. Oh, maybe so. Yeah. Okay. Yeah.
It's been a long day, man. I had my
Oh,
first unknown lab today. I'm like all over the place.
No, it is long, and I still, this is a long Zoom class at the end of the day, yeah, I mean, I totally hear you, and I don't know, and by the way, I'm glad Sylvie's back, but Sylvie, did you have a question? I mean, do you have a
She
question?
was in my group with me, and
Oh,
then I
okay.
guess she came back because our other group member just kind of disappeared, like just left the group. It was really weird.
That's a little weird. Okay. So I'll call back the rest of the people in a minute, but but wait, did you work on, wait a minute, so you were just working on but did you, does that mean you got stuck on the barn door thing or I mean?
A little bit, yeah.
Yeah, we did.
We like
Oh,
discussed it and tried it, but
okay. Oh, and thank you, Sylvie. Oh, that's Sylvie's voice. That's awesome. That, okay. Okay. Just, do you think, you stuck? All right, I'll bring everybody. All right, you know what? Okay, no, I appreciate that both of you are trying, and I do appreciate that it's the end of the day and all that. All right, give me 1 sec. I'm gonna call everybody back in a minute. I'm just gonna clear my head for, I wanna rethink strategy here for a second, because I know we're all fighting.
It's cool, no problem.
Thank you, I appreciate it. Sylvie, by the way, just getting to know you better, are you also a CMB major?
Yeah, CMB.
Cool. All right. Awesome. Okay. All right. Yeah. Give me 2 seconds. I'm going to think about something for a second, and then I'm going to call everybody back. Hold on. Okay. Okay. Yeah, I'm going to bring these people back. Okay. All right. I feel like, okay. I know we're all having our own individual tough times. And I know some people, I can tell, by the way, electronically, it is visible on my side that certain people just fade from the breakout rooms, just saying. And that's not like necessarily the best thing to do to your colleagues, but we'll discuss that another time. Okay. I've talked to some people from some of the breakout rooms. I'm a little worried that it seems like I shifted gears because I felt like we were hitting a wall somewhere else, but I'm a little worried that we hit a wall with this too. Does anybody want to save me or save the class and share anything on the problem that we're now, I'll reshare the screen. I'll try to reshare the screen. Is there anybody that feels like ideally publicly, but even in direct chat, can anybody share any findings or give me a report? Can anybody give me a report of anything productive that happened in their breakout room? You could do it publicly or in the direct chat. Give me something to work with here so we're not all frustrated. Or did anything productive happen in any breakout room? Or if not, can you explain what wall you hit in the breakout room? That would be.
I did part A.
Oh no, that's great. I got the impression you did.
I did that just sitting here, but I don't know. That's something. So
that is definitely something. Part A, I mean, there's only 3 parts. Part A is big. No, that would be
okay.
really, all right. So in fact, no, that's awesome. And wait, and good. You're going to take over in a second, but and everybody else too. Like we're all trying to
I
work
don't like
together.
that, but okay.
Well, I mean,
I'll become teacher.
no, yeah, you. Oh, wait. Oh, cool. Oh, and someone's in the direct chat. Okay, wait. I'm getting a little bit more encouraged. Okay. Oh, wait. To degrees. Oh, part A. Okay. Okay, I see something in the direct chat. That's good. 2 degrees. Hold on 1 second. Hold on. I'm just. Okay. Can I get. So Ashton's about to do some stuff. One person in the direct. If I can get, I'm going to wait for a couple. Okay, hang on 1 second. I want to get a couple more. I'm going to wait till a couple of more reports come into me to the direct chat. Just report anything. Just tell me what you tried, where you hit a wall, like what you did, just where you got stuck, just anything. I want a couple of more reports in the direct chat of why, because we got to be trying here, people, everybody. I mean, I'm going to turn the mic over in a minute to Ashton, but I also want to wait till at least 2 more things come in the direct chat. I'm going to respond to the one that's in there right now. I'm going to wait for, I'm waiting for at least 1 more report in the direct chat of anything that went on. And again, and people, like seriously, we all do have to be, it's very late in the day. I know. And it's late for me too. And this is tough and Zoom is, but we still, if you guys give me something, I can work with it, but you got to give me something to work with, if you know what I'm saying. So, okay, there we go. Oh. Okay, I'm seeing something in the chat. I'm reading. Wait a minute. Oh. Wait. Oh, okay. Now I'm getting things in the chat. Okay, good. Oh, yes, yes. Okay. First of all, also, see, this is helpful, people. Even if you're telling me in the chat, like that your room got into an argument or you hit a wall, like to know where you hit a wall or where the frustration is, I guess is all I need. Okay. Thank you. Okay, hold on. I will start talking in a second again. And also we're trying, we all don't. Oh, that's very nice. Thank you. Huh. Okay, hold on a second. Huh. Okay, I'm just responding and then I'll. Okay. Okay. Now I did just get you. I really appreciate the feedback that I just got in the direct chat. I mean, the report stuff came in. I feel much more like things are happening. Because again, and I apologize if I'm sounding stressed or whatever. Okay. Now I got something to work with here. I see what's happening. Okay. I'm going to just walk through it. I think that's the best thing to do at this point. Oh no, Ashton was going to walk through. We're going to have Ashton walk through A, I think, if she still feels comfortable doing that. Then I'll walk through the rest. But then I did get a good point in the direct chat about calculator use and how to deal with 2Pi and stuff like that. I think I do understand what that was about, and I'll address it. Couple of quick things. If there's a main takeaway, well, okay, I'm going to switch. I'm going to do the dangerous thing. Actually, you know what? With all due respect, Ashton, I'm not going to put Ashton on the spot right now, just because I'm watching the clock, and I'm not Ashton. I'm totally psyched that you were ready to go. I'm going to just do this if that's okay, because I want to keep this straight a certain way. So I'm going to change the board. I'm going to. Okay. Okay. I'm going to summarize what's on the board right now. In a way, is my main notes to address pretty much the ideas that I saw in the chat. I'm going to get answers in a second. I'm going to get answers in a second. But the main thing that's happening right now, the main thing you want to know is that a cycle from here on in is 2 pi radians, or 2 pi radians equals a cycle. A radian, so a cycle is 2 pi radians. A radian is therefore a 2π of a cycle. What do I mean by 2π? Well, pi is a number. It's approximately 3. So 2 pi is approximately 6. So there's approximately 6 radians in a cycle. What is a radian? It's approximately a sixth of a cycle. But let me say that again, or say it a different way, because radian sounds like a unit, and pi sounds like a unit or some fancy variable or something like that. Pi is just a number. It's a weird number, but it's just a number. And radian is not actually a unit any more than the word cycle is a unit. A cycle is not a unit. It's just a concept. What do I mean when I say it's not a unit? I mean, it's not a meter or a kilogram or a second. A meter is a region of space of a specific size. 1 meter is always the same size. 2 meters is always 2 times that size. A kilogram is always the same size. A second is a standardized size of time. There's no standard size of a circle or of a cycle, right? A cycle is not a unit. It's just a word for a concept that comes in all kinds of different sizes. A radian is just a fraction of that concept. A radian literally means a sixth of a cycle. I mean, a 2π of a cycle, which means a little bit less than a sixth of a cycle. And that's not a unit. That's just a concept, right? A hertz is 1 cycle per second. So a megahertz is 1,000,000 of those, 1,000,000 cycles per second. Now our calculator is always going to be in, so I'm addressing like the larger concepts that I saw in the chat, and then, which were good. And then I'm going to get the answers. Okay. And then we'll probably go to bed or dinner or whatever. Our calculator should always be in radian mode. But yes, if you're starting to get used to these equations that I had on the other sheet, if you're starting to get used to this idea that almost every time, invariably, we're converting back, invariably, we're converting back and forth between cycles and radians. And the conversion factor is just what I just keep saying, that there's 2 pi radians to every cycle. 1 cycle equals 2 pi radians. Now, we never need degrees anymore. I'm not saying this critically. I'm just saying it firmly. Like, yes, 2 pi radians equals 360 degrees, and I understand everybody's much more used to degrees. You've known about degrees since you were little kids, but the only good thing, but degrees are, again, when you think of 360 degrees, what you think of is a full circle, right? Everybody knows what 360 degrees is because they think of a full circle. From here on in, I just want you to think of 2 pi radians as that, a full circle. Like, you never have to convert to degrees again. We're converting back and forth between radians and cycles. 2 pi radians is a full circle or a full cycle, and pi radians is a half a cycle or a half a circle. When you want to divide by 2 pi, I'll do it in a minute. I mean, I heard that in some of the rooms there was like people were working and making progress, but they hit a wall or something because of issues with the calculator. And yes, you're correct that your calculator should be in radian mode, but yes, you're also correct that when you divide by 2 pi on your calculator, that can get into difficulties, regardless of whether you're in radian or degree. I totally agree. When you divide by, we'll do it in a minute, but just as a general warning to everybody, if you ever want to divide by 2 pi on your calculator, you have to be very careful because you can't just divide by 2 pi. You either have to divide by 2 and then divide by pi, like literally as 2 drawn out steps. I don't know if you thought about this or not, if you tried this, but either you have to literally divide by 2 and then divide by pi, or divide by parentheses, like depending on how expensive your calculator is. If your calculator has parentheses, then you can divide by open parentheses 2 times pi, close parentheses. You have to do one of those. You are absolutely correct. Like those of you who wrote in, and it was more than one of you who wrote in the chat about like we got into issues about the numbers. If you just divide by 2 and then hit pi, yeah, that's not going to work. I mean, but it'll look like it works because it'll get you something, but it's not what you're ending up doing. If you do that, you're in effect, you're dividing by 2 and then you're multiplying by pi. Usually, if you do that, I don't know if that address, maybe put in the chat, but we'll see in a second. But if you tried it 2 different ways and got 2 different answers, the way that's correct is if you literally dragged it out and divided by 2 and then got your answer and then divided by pi. Like that's actually, otherwise it's anyway, well, hopefully that. So all right, I'm going to quickly get, unless I'm going back and forth. I mean, okay, now I'm going to leave it to you. I don't want to put anyone in the spot. Ashton, if you would like to do part A, that would be lovely. If you don't want to, it's fine. But I mean, I'm talking so much, it's probably bad for everybody. So Ashton, if you want to take it away from, I mean, I didn't look at your answer, so I don't know for a fact you're right, but if you want to take it away, rock it.
I mean, like, I can just explain my thought process with it.
That'd be great.
I don't know if it's completely right, but I like tried something. So
No, that's
hopefully
good.
that
And I'm
works.
gonna, and do you want to share your screen, or do you just want to, because you're welcome to if you
It's on my iPad though, so I'd have to join the Zoom on my iPad in order to share the
Oh,
screen.
oh, I don't mind if you do.
Uh,
Oh, no, okay. Okay, no, just talk.
it's
Oh, sorry.
just talk. Got it. No, you're good. You're good. So I started with, because it's like saying cycles per hour, and obviously like all of our units so far are in like cycles per second, or everything's with seconds. So I was like, okay, so we're obviously gonna have to like convert to hours. So I started with the, what is it? The F, what does that mean again? I forgot. F, whatever the F unit is. I started with that one because it equals cycles per second, and that's what we're trying to find. So I knew with that we were gonna have to times it by 1 over like 60 or something, or 60 over 1 in order to find cycles per hour.
Okay.
Something, I think it would be 60 over 1 because it'd be canceling out the times or whatever, but whatever. Something like that.
No, I'm listening. I'm with you.
I probably did it wrong, but
no, I'm with you. This is good, and I'll retranslate when you're done. But no, I'm with you. You keep going.
okay, cool. So we know that the angular frequency equals the 628 radians over seconds, and we also know that W equals, or angular frequency omega whatever equals 2 pi times F. So since we're looking for F, I divided by 2 pi by both sides.
Good.
So I did 628 divided by 2 pi, and I got 986.46 cycles per second. Then I timesed it by, I should have done 60. I did a 1 over 60, so I know that's wrong. But I should have done it the other way around. I wasn't thinking, but that's what I tried to do.
No, okay. No, this is actually very helpful. And I mean, yes, I do agree with your last correct, but okay, but the first thing is totally correct. I'll re-explain it when you're, but no, you keep going.
So obviously I did that wrong, but if I redid it now on my calculator, so just give me a second. So 986.46 times, it would be just by 60. So be 60 over 1. So, but I get like a large number. It's like 59,187. Okay. But I think I did that wrong.
Okay. No, I will reach out. Okay, couple of things here. No, and I will do it in a second too. But to summarize, first of all, what Ashton said, the main, and I'm going to do it for everybody. I'm going to do it on the board in a second. And again, we'll go home soon. But the first thing Ashton said is that she divided this number by 2 pi. Or she wanted to, or that's what she felt she should do. And I totally agree. Yes, we're going to divide this number by 2 pi before we do anything else. And yes, if you're thinking, all right, I'm going to switch the screen. If you're thinking in terms of equations, she is right. Like one of the equations that we've written down that's totally applicable to this is omega equals 2 pi times f. That's what she's talking about. And the F that she was asking, what does that stand for? F stands for standard frequency. So here, I'm going to switch the screen. Oh, wait, and there's something in the chat. Oh, nice. Oh, wow. Nice. Okay, I'm just looking at what's in the chat here. I see some that I might. That's awesome. One second. Hold on. The screen sharing goes back and forth. Okay. The first thing that Ashton is saying, and I definitely agree with, is this. Okay. This is the first thing she's using is definitely correct. To review, what F stands for is standard frequency. F, which means the number of cycles per unit time per second. That's the unit of F. And the name for that unit is a hertz. Okay, this is what, and that is one of our equations, and that's what we're going to use in a second. That's what Ashton's talking about. And what we're saying on these 2 pages is the short version of what Ashton is using it. And this is the question I asked before we all went to breakout rooms and stuff like that. We're just saying, look, there's 2 pi radians in every cycle. So if I come along and say, oh, that thing did 6 pi radians per second. It completed 6 pi radians per second. That if I say that thing had an angular frequency, if I say that oscillator had an angular frequency of 6 pi radians per second, it doesn't sound like I'm saying anything meaningful to any of us. Like an angular frequency of 6 pi radians per second, what does that mean? But if you just remember that there's 2 pi radians in every cycle, then we just divide that by 2 pi to get a standard frequency measured in cycles per second. If I say something's going back and forth at 6 pi radians per second, divide by 2 pi, and it means, oh, it's completing 3 cycles per second. This is what Ashton's using. This is what I'm going to use for this problem right here. The only annoyance is that this problem suddenly makes me worry about hours instead of seconds. So I've got to be really careful about that. But that's what I'm going to do. So, all right. So here in the problem, we say, this barn door thing, we say here in this problem, and I'll show you where I fully agree with Ashton, and then I'll show you where things got like a little departed and got into the calculator issue that some people were talking about. So here's 3. It says that omega is 628 radians per second. And note that 2 pi is approximately 6.28, right? Like pi is like 3.14, 2 pi is approximately 2. So A, where it says how many cycles per hour, it says, oh no, it just lost. Oh God, come on. Sorry. Is it? Did I just lose? Wait. Was I drawing on the board did you see the board at all any of that time? Oh, I don't know. Wait, I lost the board again, didn't I? Hold on. Okay. What problem A asks is, given that omega equals 628 radians per second, what A is asking is, can we compute the frequency, the standard frequency? Can we get cycles per second? But can we convert our answer into cycles per hour? Like, that's really what it's asking, right? So first, in order to compute F, so I'm doing what Ashton said. I'm going to first just get an answer in cycles per second. And then I'm going to look, since the question's asking about cycles per hour, I'll convert it to hours. So in terms of converting this to cycles per second, like Ashton said, omega equals 2 pi F. Therefore, F equals omega over 2 pi. I'm just going to divide by 2 pi. And 2 pi basically is 6.28. So I think, first of all, F here is 100 cycles per second, or in other words, F equals 100 hertz. Now, I'm not done with the answer. I'm going to have to convert to hours in a second. But before I go any further, I know this is where some people are writing in the chat about calculator issues and stuff like that. Like, first, notice I'm just treating 2 pi as approximately 6.28. That is a perfectly reasonable thing to do. Like, first of all, that is a reasonable thing to do. We have to chop off digits somewhere. But second of all, it's a very reasonable thing to do when a problem seems constructed along those lines. That number 628 is too coincidentally, it's just too nice to not take advantage of. It's there for a reason. So when I divide by 2 pi, I'm dividing by 6.28 and getting 100. If you want to do that on your calculator, you certainly can do it on your calculator. And if you divide by exactly 2 pi, it still won't be exact. Even your calculator is chopping off digits. But do I have a calculator here? If you do it on your calculator, if you take 628 and divide by 2, you get 314, and then divide by pi, i.e. 3.14, you won't get exactly 100, you'll get like 99 or something like that, and that's totally fine. That's completely acceptable answer. But if you get something else, like it was in the chat, I don't remember, if you get something like 5,099 or something, no, then yes, you've done something wrong. Wait, I'm looking in the chat right now. Yeah, I'm saying, wait. Oh, right. So you good, wait. I'm seeing a couple of things in the chat. It feels like people are with me because they're saying things that, so I'm saying the omega was, yeah, in the document, like omega was given as 628 radians per second. The equation I'm using now, if you like, is I'm solving for f. I'm saying f equals omega divided by 2 pi. So we have to do 628, because that's what the given number was, divided by 2 pi. Now you can be exact on your, if you want, you can press the button that's called pi on your calculator. But here's the thing, even that button is chopping off digits. It's just, right? It's not going, I mean, it's leaving more digits after the decimal. Right, but wait, but I guess I'm trying to say to everybody, it doesn't matter. I totally appreciate what you're putting in the chat, all of you. But it doesn't actually matter what mode your calculator is in for this. Like, it won't matter what mode your calculator is in, because we haven't actually said anything about radians or anything to the calculator yet. Like, I'm saying you can use the button that's called pi on your calculator, but don't think that that's, I mean, that's slightly more accurate than just calling pi to. Oh, okay. Okay. I'm just reading the chat. Okay. I think everybody's with me, but you could divide by 2 pi, but you have to do it in 2 separate steps. And if you do divide by 2 pi, like the button pi on your calculator, you're right. You won't get exactly 100 like I am. I'm conveniently calling 2 pi 6.28 because I'm taking advantage of the numbers here. You won't get exactly 100, but if you get like 99 or something, that's completely fine. But if you get something like 5,099 or something, then no, then you're not doing it right. Wait. Oh yeah, I'm looking back up in the chat where someone, when you divide 628 by 2 pi, which calculates, yeah, if you get 986, it is a mistake in the way that you're using your calculator, to be honest. Like right, if you divide, okay, I'm looking at the chat now. If you divide 628 by 2 and then by pi, that is the correct way to do it. You'll get like 99.95. That's fine. But if you just write 2, okay, I think it's clear to everybody. I think so far. So I'm saying F equals approximately 100 hertz, but that's 100 cycles per second. Right now, that would be the standard frequency. But now the problem is asking for cycles per hour. So I got to do a conversion here. Now, this is like chemistry, and we just have to be careful. I will tell you right now, I mean, there's 2 things to be careful here. We're converting seconds to hours. So first of all, yes, 60 is a magic number here, but don't forget there's 60 seconds in a minute, and then there's 60 minutes in an hour. So you're actually going to use the 60 twice, or you're going to do 60 times 60, which is 3,600, right? It's not just 160 conversion, it's 2, because we're going from seconds to hours. But now I'll do it on the pad here. But the thing that always gets people in chemistry, I mean, look, and I know everybody hates unit conversion until they don't. Usually what happens with people with chemistry and stuff is they sort of get used to that. They know for a lot of you, you know what the conversion factor is, and then you just never know whether to multiply or divide, or at least if you're like the way I was, like that was always my issue. I knew what the conversion factor was, but I could never keep straight whether I'm supposed to multiply or divide. Well, I could show you different tricks for that, but one trick is just this: just stand back and think about it in English. Like, don't try to get big picture thoughts about these things. We do tend to grind a lot in chemistry, and it kind of gets in the way a lot of the time. Some of my best friends are chemists, don't get me wrong, but I'm saying, like, instead of memorizing rules, we have cycles per second here. We want cycles per hour. Just think about it in English. if you're running 4 laps every second, are you probably running more than 4 laps or probably running less than 4 laps every hour? Like if you give yourself more time to run these laps, are you going to run more of them or are you going to run less of them? I'm looking at you. See what I'm saying? Oh, there is stuff happening in the chat. Oh yeah. So no, none of this is silly. First of all, the only thing silly is for everybody to give up and tune out. No one who's doing anything today with this is being silly, like honestly. But I will say, yes, Marina, right. What you're saying is what I'm trying to say. I'm saying, to cut to the chase, I believe now I better take this number 100 and I better multiply it by 3,600 to get cycles per hour. I mean, I think if I'm doing 100 cycles every second, then every hour I'm doing a heck of a lot more cycles. Like, so I'm just saying as to whether to multiply or divide. If I divide, I'm going to get a number even smaller, smaller than 100. I'm going to get a number smaller than 1. I think I want to multiply here to get a bigger number. So but if you want to think about it in terms of like, so I agree with Marina, thank you. And I don't agree with Ashton that she's being silly. Just kidding. But really, wait. Oh, that's cool. Oh, okay. Oh, cool. And yeah, I think, and right, to get the actual answer, I think you're missing a 0. I agree, Marina, but here, right, but good concept. So in other words, look, the frequency is, if you want to be careful about it, 100 cycles per second times 3,600 seconds in every hour, right? If you want to be careful about this or see it written out like in a chemistry way, yeah, no, we're all of us are fried. We don't have to, and also I'm doing the same thing you guys are doing, which is not just that I'm making mistakes, but I keep apologizing for my mistakes. We all got to get over that. We should be apologizing for apologizing. Like, do you see what all of us are so nervous about? All of us, including me, all of us, every time we make one mistake, we apologize like 3 times. This is like a curse of science. We want all of us, including me, maybe most of all, including me. I mean, because people have been mentioning to me in the chat that like I'm sounding stressed and stuff, which I mean, I am. We should feel fine about ourselves as long as we're doing stuff, like really. But anyway, I do think this is the answer, what I just circled on the board. But I also just want to pause for a second. If our brains are fried too, the other thing we could be doing is try to use this time to work on how do you deal with a fried brain? Like, what should we do? Like, who are we kidding? If we were taking an exam, we'd be stressed now. And we want to have good habits to deploy even when we're stressed or tired. So as to when you're doing unit conversion, like, look, honestly, unit conversion is always confusing when there's a per involved. Whenever it's like cycles per seconds or cycles per hour or miles per minute, whenever there's dividing already involved in the units, everybody gets freaked out by that. The only people that don't are the people that think they don't, and then they make even more mistakes. It's definitely a bumpy thing when you already have dividing involved in the units. So my 2 tricks for that are, one I already said, just stand back and ask yourself, do I want the number to get bigger or smaller? If I want the number to get bigger, I'm going to multiply. But the other way to see it is you always, like the way I actually do unit conversions, if you look at the top line of what I'm doing here, this is going to bore most of you, but it's going to help like 3 of you. And I have no idea who the 3 are. But if you look at that top line, you notice that actually the trick is always multiply, just always multiply, always multiply by a fraction that equals 1. Always multiply by a fraction where the top equals the bottom, right? Because you're always allowed to multiply by 1. It doesn't change anything. So you always want to multiply by the well-chosen 1. Your unit conversion is going to, so it's either, you're either multiplying by 3,600 seconds over 1 hour, or you're multiplying by 1 hour over 3,600 seconds. Like what I'm saying to all of you is, forget about asking yourself, am I going to multiply or divide? Always multiply by a fraction. The fraction is always the unit conversion thing, like 3,600 seconds is the same as 1 hour, right? They're both the same. That's why they equal each other. That's why you're allowed to multiply, because it's like having 7 over 7 or 9 over 9 or x over x. The whole thing equals 1. That's why we're allowed to multiply. My suggestion to all of you, if you've never thought about this before, is always just multiply by a fraction. The fraction will always be like the unit conversion in one part of the fraction and the number 1 and the other part. The only question is the 3,600 going on the top or is it going in the bottom? Like that's always the question, right? And the answer is you just put the units where they can cancel out. In other words, I knew to put the 3,600 in the top because 3,600 seconds equals 1 hour, and I needed those seconds, the 3,600 seconds, to cancel out with the seconds that are already in the denominator of cycles per second. I need the seconds to cancel out so that I'm left with cycles per hour. That honestly, that's how I do unit conversion, is I always just multiply by a fraction, and I just choose of which to put on the top of the fraction and which to put on the bottom. I choose by asking myself, what do I need to cancel out? Like that always works. I remember the day that I mean, it didn't occur to me. Someone showed it to me. I was probably 40 years old when someone showed me to think about it that way. Like I was way out of college at that point, out of grad. I was in whatever. Anyway, if it helps anybody, then good. But anyway, I think that's the answer to that. So I know we're almost done for today, for good or for bad. That's the answer to that. I'm just gonna finish this problem and we'll be. So then B is measured in megahertz. What's the standard frequency? Okay, so now we still have the frequency, right? The frequency equaled 100 hertz. We already got that in part A, but now it wants it. We want the frequency in, sorry. Now we want it in megahertz. That's the question, right? Well, so a megahertz is 1,000,000 hertz. What 1 megahertz equals 1 times 10 to the 6th hertz, just by definition. Mega means million. So this is another one of those things. We're either going to divide by 1,000,000. Actually, I'm going to ask the class. We are almost done today. We're doing great, guys. We're hang in there. For this one, we already have it in hertz. It's 100 hertz. I mean, I believe, right? 100 cycles per second, right? Yeah, we have it in hertz. We want it in megahertz. A megahertz is 1,000,000 hertz. This is just a straight up unit conversion. We're either going to multiply by 1,000,000 or we're going to divide by 1,000,000. I ask you, think about it. I'll show it. I will write it out. But think whatever trick you want. Either just stand back and think about the logic of it, or do the cancellation thing that I just suggested. But someone in direct chat, I'll wait till there's 2 people in direct chat, not public chat. In direct chat, I'll wait till there's 2 answers in direct chat of whether I want to. I'm either going to take 100 and multiply it by 1,000,000, or I'm going to divide by 1,000,000. Am I going to multiply or divide? I'm waiting for the direct chat. Ooh, that was fast. I'm not saying if it's right or wrong, but that was fast. Okay, I got 2. Okay, I'm going to actually answer. I got 2 different answers, so I'm going to wait till there's a tiebreaker. I want 1 more answer in direct chat. I'm either dividing by 1,000,000 or I'm multiplying by 1,000,000. Okay, awesome. I'm saying awesome because I've now gotten 3 people, and I'm noticing, by the way, guys, as much as I'm yelling and being all stressy, I am noticing that almost every time I ask for stuff in the chat, I'm getting like a nice variety of people. It's not escaping my attention that some of you who don't talk like a lot or as much as others are definitely talking to me in the chat. I really appreciate that. Like you're coming in at key moments. So, okay. All right. And now I'm getting a lot in the chat now. Okay. And I know it's getting, and I really appreciate it. I'm not going to respond to every one of you directly, but I see you. There's like 5 of you, 6 of you. And every single one of you is answering my question. You definitely are answering my question. So you're like, my question was, am I going to multiply or divide by a million? Every single one of you answered. Okay. And now I'm going to say, interestingly, the overwhelming majority of you in the direct chat said multiply. To be honest, I think the answer is divide. But I'm glad that we're all together on this question, but it sounds like this is worth me saying. I think it's divide. And here's why. I'll show you both methods. And it's not meant to be a trick question, but I know it is tricky, especially late at night. This thing is doing 100 cycles every second. Now, the question is asking, how many millions of cycles is it doing every second, right? Like if you think about it, so to cut to the chase, I think, well, it's going to do a lot fewer. It's not going to do a lot more. Like the last question, part A, we said this thing is doing 100 cycles per second. How many cycles is it doing every hour? So we like gave it a lot more time and asked, is it going to do more cycles or fewer cycles? And we were saying last time, well, it's going to do more. Like if it's doing 100 cycles in a second, but you give it a whole hour, it should do a lot more. So we multiplied. But here we're asking the opposite kind of tweak. Here we're saying it's doing 100 cycles every second. Now we're saying, so in a second, how many millions of cycles does it do? Like we're right. I mean, it's almost like saying I have 36 eggs. How many dozens of eggs do I have? Well, a lot fewer. A dozen is a lot of eggs. Like if I have 36 eggs, I only have 3 dozen. I mean, I don't know if that's a weird example, but that here it's saying if you're doing 100 cycles every second, how many? It's not changing the time. We're still looking at seconds, but it's asking. So it's not saying how many cycles are you doing in a megasecond. It's saying how many megacycles are you doing in a second? How many? So I am thinking it's going to be divide. And if I want to show it like in the cancellation way, I would say 100 cycles per second times. Okay, so now I'm going to do, so this is where I'm going to do like, I have to convert to million cycles per second, right? So I'm going to multiply either by 1 million cycles in every cycle. I'm sorry. In other words, right? So look, I have hertz, 100 hertz. I want to convert to megahertz. So I know the conversion is that there's 1 million hertz in every megahertz. So the question, so I'm either going to multiply by 1 million hertz over 1 megahertz, or I'm going to multiply by 1 megahertz over 1,000,000 hertz, right? It's 1,000,000 hertz equals 1 megahertz. The only question is whether to put the million in the top or the bottom, but I've got to put it in the bottom so that the hertz cancel out and I'm left with megahertz. So the answer I get is 100 over 1,000,000 megahertz. In other words, 0.00001 megahertz, or 1 times 10 to the negative 4. Did I do the right number? Sorry. Megahertz. Ultimately, I'm saying divide. I know now it's 7:02. It's just about okay. Let me leave in the chat. But I'm saying divide. I'm saying it's got to be, the answer's got to be smaller. But I know most of you said multiply. So I mean, I don't know if this clarifies it or not. Wait, did I look at it? I'm saying divide by 1,000,000. Take 100 and divide by 1,000,000 is the answer to C, because we to B. I don't know. I'm just going to go on. I mean, tell me if in the chat if you want me to say more about that. But it does. Okay, good enough for me. Thank you, direct chat person. Cool. So we'll do one more, and then that'll be the day. So the last one. This one actually. So this one we don't get into millions or any of the confusion or hours. This one's straight up. Maybe this should have been the first question of all these. But remember, for C, we know that the frequency is 100 hertz. In other words, 100 cycles per second. So the question is, what is T? Yeah, I'm going to cut to the chase on this because we've got 6 minutes left. I'm going to cut to the chase on this. Then I'm going to give you the final answer to the thing that we were working on all for the first hour, just so we have closure. But then, by the way, with those two things, then I think we're done. Like, I think then you have everything you need to finish this homework. And we will have, it turns out we've done a lot of it together, which is fine. But so the last question is, what is the period measured in seconds? Well, this is more straightforward. If I gave you more time right now, I'm pretty confident that most of you could do this now. If the standard frequency is 100 cycles per second, period is measured in seconds per cycle. So the period is just the reciprocal of the frequency, always. Like always, this is true. Omega equals 2 pi f, but f always equals just 1 over t. And t therefore is 1 over f. In other words, I think the answer to this, to get straight to it, I think the answer is 100th, or in other words, 0.01 seconds. The period is 0.01 seconds. I mean, if this thing is doing 100 seconds per cycle, then it takes 100th of a second to do a cycle. That's it. I can't say much more about, I mean, I'm sure I could, but I'm not going to say much more about that now. That's the answer. That's my handwriting is ex-murdery. 100. Now, the last thing I'm going to say on the last page, just to summarize, to bring this all full circle in the last 4 minutes, and yes, and you've been very patient, honestly, to bring this all, oh, is there something in the chat? I'm sorry, there's a lot in the chat. Sorry. Yeah, sorry. Yes, it's a very quickly oscillating barn door. It's ridiculous that we call that a barn door. That's true. Oh, and good. Yes, direct chat person who put 0.01 second. Oh, good. Sorry, I missed this. But yeah, cool. Everything that's in the direct chat since the last question, it looks like you guys are really with me. Thank you. Yes, like 0.01. Very good. But yes, it's a very quick barn door. It has a speed stat of 28. But it does the move agility, so it raises its speed stat, whatever. Okay. So to bring this all full circle, that problem that we just reviewed, all the stuff that we're reviewing, like the radians, the cycles a second, they're all about the concepts of omega, F and T, angular frequency, standard frequency, and period, all the different ways of describing oscillation. But what the whole original premise of today's class was like somehow or another, this omega, F, and T, they're all somehow being driven by or determined by the K and the M of a spring system. Like that's actually where this all ties together. What we were playing with is that somehow T must be based on the square root of M and 1 over the square root of K. That's what we were playing with at the beginning of this class. Somehow, but remember, if we know T, then the reverse, and someone put this in the chat, if we know T, then the reciprocal of it is F. But if we know F, and we divide by 2 pi, we get omega. I'm sorry, if we multiply by 2 pi, we get omega. But if we divide 2 pi by omega, we get T. All of these things are related to each other. The units all have to work out the same. But somewhere a 2 pi has to be in there somewhere so that they're all linked together, right? And 2 pi doesn't change the units of anything because a radian is not a strict unit, right? A radian is just a portion of a cycle or a circle. It doesn't have any specific size. So at the end of the day, to put it all together, what I'm going to say is this. I'm just going to say it so you have it and you can use this for the rest of the homework and use this for the rest of your life. At the end of the day, it's omega that literally equals the square root of K over M. Omega is the square root of K on top with the square root of M on the bottom, okay? Then F is the flip of, F is all that divided by 2 pi. So the square root of K over M divided by 2 pi. And then period is the flip of that. So 2 pi times the square root of M over K. In other words, what I'm saying, and again, one person did put this in the chat like a long time ago, and I commend that person. I'm saying, you could take this to the bank now from here on in. What we figured out was the units. We correctly figured out that the units of period must lead us to the conclusion that period must be based on the square root of M over the square root of K. For sure, that's correct. And similarly, then the units of F must be the square root of K over the square root of M, like the flip of it. And the units of omega had to be the units of square root of K over square root of M. But somewhere in there had to be a 2 pi weaved through, right? That's how they all relate to each other. And there's no way from units we can know exactly where the 2 pi is. The units can't tell us because 2 pi doesn't have any units. So 2 pi had to be in there somewhere. And since omega equals 2 pi over T, like the T has to have a 2 pi in it so that you could divide that out and get omega. If that, I said that fast, but that's something so that's the bottom line is T in the end of the day. If we were looking for what that constant was, the C, the constant was 2 pi over the square root of K. I'm going to just leave you with that for now. I know, and then next week we'll talk about the other lab and we'll take a break. We'll take a break at some point soon. I know we all need it, but we'll certainly take a break tonight. There's no new homework. Just keep on keeping on. Catch them all, blah, blah, blah. You've been very kind. Okay, have a good night. Dinner, fun stuff.
Have a good night, Professor.
Have a good night, everybody. Thank you, guys.
Wait, don't.
Good night.
I'm here. Oh, good night. No, I'm here. No, if you
Have a good night.
have a good night. Have a good night. You guys were great. But I'm not going anymore.
No, I just wanted to finish copying the love song.
Oh, okay. Oh, yeah. Okay.
I know you posted notes, but mine as
Okay,
well.
thank you. No, yeah. Thank you for reminding me.
Okay, thank you. Have a good one.
You too. Thank you. Bye. Bye.